Let's try to understand inverse of a function. Inverse of a function. As you know, function performs an operation on the input to give you a specific output. Let's say this is a machine which performs this operation. For input x, we get an output y. So this is a function. Now inverse of this function will be a function which can do the reverse operation. That is, if you get y as your input, your output should be x. And we write this as f inverse of x. We'll denote inverse of a function as f inverse x. So, it is basically inverse of a function reverses the operation of its function. Now, let's take a concrete example. Let's say this machine performs the operation 2x plus 1. If the input is x, the output y is equals to 2x plus 1. So for input 1, we get the output 1 times 2, 2 plus 1, 3. For input of 2, we'll get 2 times 2, 4 plus 1, 5. For 3, the output will be 3 times 2, 6 plus 1, 7. For 0, the output will be 0 times 2, 0 plus 1, 1. So, this function performs an operation of the inputs. Inputs could be any real number giving us outputs, so that the input is multiplied by 2 and then you add 1. So we have 0 will give us an output of 1. If 1 is the input, it gives us an output of 3. If 2 is the input, it gives an output of 5. And if 3 is the input, it gives us output of 7. So this is how we have defined our function f. Now, inverse of this function should do what? Inverse of this function should do transformation from here to this, or the mapping, reverse map. So it will do reverse this operation. Earlier operation was to get 5 from 2. Now from 5 we should get 2 back. That. So this operation, which does the reverse of this operation, will be inverse of this function. Okay, I hope you understand that. Reverse operation. Let me write it in ordered pairs. For the function fx, the ordered pairs are 0, 1, 1, 3, 2, 5, 3, 7. 0 to 1, 1 to 3, 3 to 5, 3 to 7, 2 to 5. Okay, this is our function. And the inverse of this is 1 to 0, 3 to 1, 5 to 2, and 7 to 3. Now, if you compare these two, fx and f inverse x, you'll find that these ordered pairs have interchanged. Here, it is from 0 to 1, and in inverse is 1 to 0. 1 to 3, it becomes 3 to 1. So basically we are swapping x and y. 2 to 5, the y value of 5 becomes here the input value, and the output we get is 2. So if from the ordered pairs, inverse can be determined by swapping swap xy, yx. Another interesting thing you see is here for the function, this is the domain, and the range is this set of numbers. For the inverse, that becomes the domain, and this is the range. This is for f inverse x. So you'll always see that for an inverse function, the domain and range interchanges. I'll show you how you can find inverse of a function algebraically. These are the steps. So write down steps. To find inverse algebraically. Our function was defined as fx equals to 2x plus 1. Fx is the output. Let's write it in the form of y equals to 2x plus 1. It helps to solve equations in terms of x and y. So first step, change fx to y. Now solve for x. First is change x to y. So here y will be replaced by x and x will be replaced by y. This becomes x equals to 2y plus 1. So we have changed fx with y here, and in this step we have interchanged x and y. So instead of y, write x. Instead of x, write y. Now solve for y. To solve for y, we'll bring this 1 this side, so it becomes x minus 1 equals to 2y, or y is equal to x minus 1 divided by 2. Now this is inverse of this function, so we can write this as f inverse x is equals to x minus 1 divided by 2. I hope you get it. That's so simple. Now let's check. Does it give us the right values? Well, let's see. What is f inverse of 3? So if I put 3 here, then 3 minus 1 is 2. 2 divided by 2 is 1. So f inverse of 3 is 1. F inverse of 3 is 1. Correct. How about f inverse of 5? If I put 5 here, 5 minus 1 is 4. 4 divided by 2 is 2. Likewise, you can check all the values. So if we input 3, we get 1. If we input 5, we get 2. If we input 7, we will get 3. 7 minus 1 is 6. 6 divided by 2 is 3. So f inverse of 7 is equal to 7. 7 minus 1, 6. 6 divided by 2, 3. So this is kind of proof to you that the equation we got is correct. Now let me show you how to write inverse from words. The equation y equals to 2x plus 1. We can say output is 2 times x add 1. Now think about the reverse operation. Reverse the operation. Reverse operation will be, here what are we doing? We are multiplying the number by 2 and then adding 1. Reverse operation will be subtract 1, divide by 2. So let's do reverse. So we say Reverse operation is subtract 1, so x minus 1. So instead of add, we will write subtract 1, divide by 2. Divide by 2. That becomes inverse of the function. So this is how we can convert equation very easily from given to inverse by doing reverse of the operation. Now let us say the equation is y equals to 3x minus 1. Can you tell me what would be the inverse of this function? Inverse should be add 1, divide by 3. Now consider the function hx as half x plus 1. What should be the inverse of this? Inverse of this should be h inverse x. Should be equal to take away 1 times 2. X minus 1 times 2. So this is how we can reverse the operation. So here, if the number is add, make it subtract, multiply, then divide it, do the operations in this fashion. Now think about this. Our function, let's say gx is equal to square root. We will do this is kind of complicated, but let's try to understand. Can we get from words inverse of this equation? Let's see what the equation says. Equation says multiply the input by 2, take away 1 and square root. It says times by 2 subtract 1 and then square root. How about the reverse operation? Reverse, if we do, reverse operation should be instead of square root, square. Square the number x and then add 1 and then divide by 2. In a way, you can write this g inverse x equals to x square add 1 divide by 2. So this way we can get inverse of this function. Let's again consider this function y equals to 2x plus 1 and see it on a graph. On a graph, you know these values, we'll use these coordinate values. If x is 0, then y is 1. If x is 1, 1 times 2, 2, 2 plus 1, 3. So for 1, we get 3. If x is 2, the value is 5. Well, you can also see 1 is your y-intercept and 2 is the slope. Therefore, we get a line like this. Similarly, we can do 0. If 0, then x is 0, y is 1, x is minus 1, then y is minus 1. And we get a line like this. For inverse of this function, so these are coordinates. These coordinates flip. This point was 0, 1. So when you flip it, it becomes 1, 0. So we get here. This coordinate is 1, 3. So when you flip it, it becomes 3, 1. So go to 3, 1, 2, 3 and it flips to this point. Here the coordinate is 2, 5. So 2, 5, when you interchange, it becomes 5 and 2. So 1, 2, 3, 4, 5, 1, 2. We get this point. This coordinate is minus 1, minus 1. So it remains there, minus 1, minus 1. So we'll join this line. This is f inverse of x. And this is your fx. Do you see some kind of symmetry here? Yes, it is very interesting to see that if we have a line going like this, then each point is symmetrical. You will find this distance is equal to this distance, this distance equals to this distance. So graphically, you can find inverse of a function by reflecting it on a line y equals to x. But a point to make here is that inverse of a function may not always be a function. Now let us consider a function y equals to x square. To find its inverse, we will interchange x and y. So let's write this as x equals to y square. Now to solve for y, you will square root it. So when you square root it, in that case, because this was a square, we have to take plus and minus. So here, this will be plus minus square root x is equal to y. Now, you know, for every value of x, you get two different values of y. Therefore, this is not a function. It is of course an inverse. It is an inverse relation of the given function, but it's not a function itself. Therefore, I can summarize that inverse of a function may or may not be a function. It is definitely a relation. Let's graph it. Y equals to x square is a graph which looks like this. Now its inverse, as you have seen, is plus square root x and minus square root x. So plus square root x will be something like this. This is y equals to square root x. And minus square root x will be like this. Y equals to minus square root x. Now you can see that this inverse of this function is not a function because it fails vertical line test. So here I can conclude that inverse of every function is not necessarily a function. From a graph, however, you can figure out whether it will be a function or not. In this graph, you can see if I draw a horizontal line, it intersects the graph at 2 points, more than 1 point. So when you find the inverse of this, then it fails the vertical line test. Therefore, if a function fails horizontal line test, we call this as horizontal line test. So if a function fails horizontal line test, then its inverse will not be a function. However, if we would have restricted this function y equals to x square only for one half, that is, only for this half, let us say consider only this part, not that part. That is, if we restrict domain to x greater than or equal to 0, then we are considering only this part of the function, the positive part. So what is the inverse of this positive part? This part. And this is a function. Because we don't have this part, it does not fail vertical line test. So one way of creating inverse as a function from original function is by restricting the domain. We could have considered that half also. In that case, this will be the inverse of the function. So restricting domain helps us to ensure that the inverse is also a function. Inverse is a very important operation. See, in many examples, like let's say you go to the market and you want to buy shirts, and let us say a shirt is on discounted rate and one shirt is costing just $20. Then 3 will cost you how much? $60. But if you have to figure out that for $100, how many shirts can you get? This is what an inverse of the function will do. So it has a lot of practical applications. Let's go back to this recap. Today we learned that inverse of the function is basically reversal of the operation. So when you reverse the operation, you get the previous value. So here you can say the function performs an operation f, gives, if x is the input, y is the output. Now, if I do inverse of this function, f inverse, then what should be my output? X. Do you see that? So, inverse reverses this and gives me output of x. From ordered pairs, we can write the set of ordered pairs, and to find the inverse, we just flip x and y values and we get the inverse. In case of a mapping diagram, change the direction of the arrows. Domain of the function becomes the range of inverse, and range of the function becomes the domain of the function. Algebraically, we can find inverse by first replacing the sign function as y, because y is the output. So y equals to, in this case, 2x plus 1. Second step, interchange x and y. We saw to find inverse, we basically have to swap x and y. So let's interchange x and y. Instead of y, write x. Instead of x, write y. And now solve for y. So we'll do simple solution. Take away 1, divide by 2. You get this. In function notation, it should be written as f inverse of x is equal to x minus 1 over 2. Inverse, we saw that inverse of a function is reading that operation in the reverse order. Here the order was times 2 plus 1. Now it becomes take away 1 divide by 2. So take away 1 divide by 2 is just reading the same statement in the reverse order to get it. Secondly, we saw on a graph, when we draw a function and its inverse, they are symmetric about a line y equals to x. So the center of these 2 points is always y equals to x. You can check it. How? Let's see. What is the middle point of these 2 points? x1, x2. So midpoint, you know formula, midpoint. Midpoint is x1 plus x2 divided by 2. So if you add 0 and 1 and divide by 2, 0 plus 1 is 1, 1 divided by 2 is half, x value is half. What about the y value? 1 plus 0, 1 divided by 2, half. Do you see? We get x equals to y. See the next value. 1 plus 3 is how much? 4. 4 divided by 2, 2. How about the y value? 3 plus 1, 4. 4 divided by 2, 2. So the middle points are always x equals to y. This is most important. This is a check whether your function and inverse function has been calculated correctly or not. Now lastly, we see inverse of a function is not always a function. Therefore, we say it will be a relation. It could be a function also. To check whether it is a function or not, we can do horizontal line test. If you draw a horizontal line and it crosses your function at more than one point, then its inverse will not be a function. As you saw in this case, inverse of parabola is a square root function with positive and negative values. So at a point we have more than one value, 2. It fails vertical line test. Well, we can always restrict the domain of our function so that it passes horizontal line test. Here we restricted our domain to x greater than equal to 0. In that case, we are working only with this positive half in the first quadrant for the parabola, and the inverse of that will be this square root function. And you will note that there is a line y equals to x. And this function is reflected on y equals to x. There are points which are common, the points of intersection of y equals. These are called invariant points. Invariant. Their value doesn't change because here x and y values are equal. So I should write x comma x. Both are same. They lie on line y equals to x. Okay. So that's it. In next, we will see many different types of examples how to determine inverse function using algebraic equations and graphs. Okay, thanks a lot.